Okay, so today we're going to talk about definite integrals. When we integrate a integral between two values, two limits we call them, and these are these things here and here, okay, we're actually finding the value of the definite integral. So the definite integral equals the integral between the lower limit x equals a and the upper limit x equals b of the function of x with respect to x. Okay, usually we don't bother writing x equals a, x equals b as the limits, okay, because it makes the work all cluttered and fussy. So we just normally write the definite integral is the integral between a and b of f of x dx. So when we're calculating a definite integral, we don't need to worry about the plus c, and this is because it cancels out. So if I allow the integral of little f of x dx to equal capital F of x dx, capital F of x, then I can write my definite integral as the integral between a and b of little f of x dx equals capital F of b minus capital F of a. Okay, so there's no need for the plus c's. Just to clarify that and so you can see why that's happening, okay, we can say, right, we use these square brackets to find the integral. So once we've integrated it, there it is, and there's my plus c. I'm now going to substitute in the values on my limits. So I do b first because that's the upper limit rather. So f of b plus c minus f of a plus c. So you can see here quite clearly that the c's do cancel out. Okay, now the other thing to remember about a definite integral is that you're going to end up with a value. You're not going to have letters in there unless, of course, the coordinates or the limits are being given to you in terms of a's or b's or p's or q's, whatever. So a couple of examples for you. So we want to calculate the integral of x squared minus 3x plus 2 dx between the limits of 1 and 2. So here we go. So my square brackets, and in my square brackets I put in the integrated form. Key thing in the questions, you must put in the integrated form because otherwise you don't get any credit for it. So here we go, we've got x cubed over 3 minus 3x squared over 2 plus 2x, and we're calculating that between our limits of 2 and 1. So the first one, we're going to put our upper limit in. Okay, so I'm going to put in 2, I get 8/3 minus 12 over 2 plus 4, minus then the value where we've put in our lower limit, which is going to give me 1/3 minus 3 over 2 rather, plus 2. I evaluate that and I get 2/3 minus 5/6, which just gives me negative 1/6. Okay, just looking at it from this time with a trigonometric point of view. Looking at it, so our limits can be in radians as well as just normal numbers. And that's a limit between pi by 6 and pi by 3 of sine 2x plus cos x dx. Okay, well that's going to sine 2x integrates to negative cos 2x over 2, and cos x integrates to sine x. And again, we've got these square brackets and our limits at each end. Evaluating, substituting in our limits, we get minus cos 2/3 pi over 2 minus sine of pi by 3 minus cos pi by 3 over 2 plus sine pi by 6. Okay, obviously I made these simplifications there. And putting all of that into our calculator, we get 0.8660. So just remember that laying out your work is quite important. Remember to use the square brackets with the limits and keep your work under each other. Now you can actually check your answer on the graphical calculator, and I'll show you how you can do that in class.